Welcome back, dear friend. Today in this video we will be talking about discriminant equations, and we will do a few more examples. We try to solve each equation by first talking about the discriminant value and then using the quadratic formula and then factorization. So this is the first examples. You can always stop the video, try to do it on your own, and then check your answers. This is a quadratic formula. If we want to use the discriminant value to estimate the number of roots, remember we have to find a value of b squared minus 4 times ac. So as you can see here, the a is 1, b is 6, c is 9, and I calculated the discriminant value, which is b squared minus 4ac, and then the final answer is 0. That means, according to this discriminant value, we would expect 2 identical roots. So once more, let's identify a, b, c, and then use the quadratic formula to solve this equation. As I mentioned, I identified a, b, c, and I substituted in the formula. I simplified and I found out the 2 roots are both located at -3. So if I want to rewrite this quadratic function, it will change into x plus 3 times x plus 3, right? Or in other words, I can just simply write it as x plus 3 to the power 2, which is equal to 0. Okay, so this is the first method, which is quadratic formula. Remember, we want to solve each of these examples with 2 methods. The other one is factorization. If you remember, this is pattern number 2. Okay, just to remind you, I will write the pattern again here. So that was a plus b to the power 2 would be a squared plus 2ab plus b squared. Okay, so here you can see that this is a squared, this is 2 times ab, and this is b squared. So if a squared is x squared, then x equals to a, and if b squared is 9, then b would be 3. Okay, and it turns out to x plus 3 to the power 2 equal to 0, which is exactly the same as the quadratic formula. So once more, no matter what method you use, your answer should be identical, should be exactly the same. Let's talk a little bit about more this quadratic equation. If it was a quadratic function, okay, and we were supposed to graph it, the a value is here is positive, so we would expect something upward, something that opens up. Whenever you do an example, let's say on quadratic or any other topic, try to just dig in a little bit more. Try to, spend a few minutes contemplating about the questions, what other information you can get from the questions. It really helps to make a solid background in your math. So let's say here the roots are -3, and what does it mean? So that means if the root, which is -3, it's substituted back in the original equation, it should be equal to 0. So let's try. So we put x equals -3 and see if it turns out to be 0. Okay, x to the power 2, it's 9, plus 6 times -3, -18, plus 9. So 9 and 9, 18 minus 18, it's 0. Perfect, right? So I checked my answer with 3 different methods: quadratic formula, factorization, and then when I found the answer, I substituted back and I made sure my answer are correct. Okay, this is the first example. Let's do another one. Okay, let's continue with the second example. Here we have x squared plus 19x plus 34 equals to 0. First of all, we want to evaluate the discriminant and see how many roots are we expecting. So first of all, first thing first, we have to identify A, B, C, and then form the discriminant. So A is 1, B is 19, C is 34. We substitute it in the discriminant formula, and we find the value to be 225. Okay, so it's greater than 0, and that means we expect 2 different roots. So let's solve this one through a quadratic formula and then use factorization. In order to use the quadratic formula, we just simply substitute all the values in. So minus b, it's minus 19, plus and minus. We already calculated b squared minus 4ac, which is 225. We simply substituted here over 2 times a. And after simplification, the first root would be located at -2. The second root would be located at -17. This is the quadratic formula, which is very efficient and always give you the correct answer, no matter what it is, like in radical format, decimal format, or fraction. This is a very good method. The other one, which is factorization, because sometimes they might ask you to use only factorization. So let's see how we can use factorization. So we are looking for 2 numbers, which we add them together, we get 19. We multiply them, we get 34. Add them, we get 19. Multiply them, we get 34. Okay, so these 2 numbers happen to be 2 and 17. So I can factorize it like this into 2 brackets, 2 binomial brackets. And then when a times b is equal to 0, either a is 0 or b is 0. If a is 0, the x would be -2. If b is 0, the x would be -17. So if you can see from factorization method, your answers, your roots are -2 and -17, which is exactly the same as the quadratic method, which is -2 and -17. Okay, let's move on to the third example. Here we have x squared plus 12x plus 36 equals to 0. So first thing first, you have a quadratic equation. You have to identify A, B, C. So we identify A, B, C. A is 1, B is 12, C is 36. Now we substitute the values in the discriminant formula to see how many roots we expect. So b squared, it's 12 to the power 2 minus 4 times a, c, and 144 minus 144, it's equal to 0. So the discriminant value is 0. That means we expect 2 identical roots. Now let's use the quadratic formula to find our location of the roots, or the value of the roots. So x1 and 2 would be negative b, which is -12, plus and minus discriminant value over 2 times a. And after simplification, we find the 2 roots to be exactly the same, both at -6. And this is exactly what we expected, 2 identical roots, which both of them are located at x equal -6. Okay, perfect. Now, just to check our answer, I can go back and tuck in this value to my original equation and make sure it's the right answer. So let's see here, I just substitute x as -6, so that would be -6 to the power 2 plus 12 times -6 plus 36. Okay, so this is 36 -72 plus 36, 72 minus 72, which is equal to 0, which is exactly what I expected. So that means my answers are correct. The second method, it's always good for practice. Try to solve as many as you can and solve from the, any method that you know. So the second one would be true factorization. Again, we use this template or this pattern, which is a plus b, the whole bracket raised to the power 2 would be equal to this value. Okay, so here x squared should be a squared. So from here we find the x to be a, and then if we continue, we will see that 36 is b squared, so b is equal to 6. All right, so that means we can rewrite the expression as x plus 6 to the power 2 equal to 0. So that means x plus 6 times multiplied by another x plus 6 is equal to 0. When a multiplied by b is 0, that means either a is 0 or b is 0. Okay, if a is 0, the answer would be -6. If b is 0, the answer would be again -6, which is exactly the same answer that we got from the quadratic formula. Two identical roots located at -6. Okay, next example, 3x squared plus 4x plus 27 equals to 0. Here we start again. Remember, always start with identifying a, b, c. A is 3, b is 4, c is 27. And I have the discriminant. I substituted in, but let's see what happens here. So here, let me just make it. B is 16. Oh, b is 4. So b is 4. Okay, so here let's substitute it in the discriminant value. B squared minus 4 times AC. B to the power 2 is 16 minus 4 times AC. And if we find the value, we would see that the discriminant, it's less than 0. It's a negative number, which means there are no real roots. That means for the sake of this video, we wouldn't continue. And remember, having no real roots, it doesn't mean we would be stopped here. If you guys are familiar with complex number, you can continue solving this quadratic and find the complex values. But if you're looking for real numbers, real roots, then you have to stop here. Let's do another example. This example here, it's rather different from the previous ones because here a is 1, b is a fraction, which is actually 1/2, and then c is actually like the whole function. It's not in the standard format, so the c would be +6, because if I want to rearrange and move everything to one side, it will turn into this thing, because I have to add +6 and +6 to both sides, right? So I rearrange everything, I bring everything to one side, equate it to 0, then I identify A, B, C. A is 1, B is half, C is 6. Then again, like the other steps, okay, so the value, we have the discriminant, we just substituted. B squared minus 4 times AC, so b to the power 2, it's 1/4 minus 4 times AC, which is -24. As you can see here again, the discriminant turns out to be negative, and that means there are no real roots for this quadratic equation. Okay, now another example. As you can see here, this is not arranged. So first thing first, we have to arrange it. And then you can see that some of the coefficients are fractions. So in order to, get rid of the fraction, I'll do, I multiply both sides by 6. So it turns into 5x squared equals 6x minus 2. And then I rearrange it. So that means I will bring everything to one side and then equate it to 0. Then I will identify A, B, C. So as you can see here, A is 5, B is negative 6, and C is 2. Okay, so the three coefficients, and then we want to form the discriminant and find its value. So b squared minus 4ac equals, we just substitute, and it turns out to be a negative number which is less than 0, which means for this specific equation, quadratic equation, there are no real roots. Okay, another example. So again, try to pause the video, solve it, and then come back for the answers. First thing first, I will multiply both sides by 10 to get rid of the fractions. So it turns out to 4x equal 2x squared plus 1. Next, I will rearrange. I will move everything to one side. So 2x squared plus 1, and then I add negative 4x to both sides, okay? And then try to write everything in order. So here, the A is 2, B is negative 4, C is 1. Now let's form the discriminant. B squared minus 4 times AC. I just substitute the value and I figure out the value is 8, which is a positive number. So I will have 2 different real roots. And then let's find the roots with the quadratic equation. Okay, so I just write down the quadratic equation and substitute the values. So it would be negative b plus and minus radical, the value of the discriminant, which is radical 8, over 2 times 2, which is 2a. So as you know, 8, okay, I just put it down here, 8 is 4 times 2, okay? And then 4 times 2 can be broken down into 2 radical 2, right? So this is what I did here. Instead of radical 8, I just substituted with 2 radical 2. And from here, what I did, I tried to actually simplify it one step. So what I did, I factorized a 2, so it turns out to 2 plus and minus radical 2, okay? So this top turns into this one, and then I simplified this one with this, and one answer would be 2 plus radical 2 over 2, the other would be 2 minus radical 2 over 2. So as you can see that the roots are not are real numbers, but they are not integers, right? But that's totally okay. If you substitute this value back into your equation, it will satisfy the equation. But let me just mention something to you. If you guys try to find the decimal value for the roots, probably you will round it up. And when you substitute it back, it would not exactly be quite equal to 0. It would be a very little number, because remember, here you rounded up the roots to find a decimal value. But if you substitute the exact value, it would become 0. I hope you enjoyed these practice questions, because math is all about practicing. Please don't forget to subscribe to my channel. See you next time.